What we have in store is, I think, pretty exciting. And there's a lot of things that we'll run you through that reinforce the tone that Steve set this morning, which is AI for the physical world. What can we actually do with AI that makes a difference to make our world better in really tangible, specific ways? And that's going to be a few minutes of my talk this morning. The questions that we've always asked about technology and where technology is going are, these questions we've been asking for decades. If things are so advanced and propulsion is so great and AI is so wonderful, then where's my flying car? If there's so much automation and people claim that robots can do everything, then where's my autonomous vehicle? And it goes on and on and on. Why do I still have safety incidents in manufacturing? If there's tremendous vision systems that can see everything and there's NLP systems that can understand all the rules and policies, why do I have any incidents at all? And when you go through these questions, what you're really saying is, where is my better world? These things all characterize the world we live in. This is not about optimizing an ad click on a social network. This is about getting from one place to another safely and more quickly in a more energy efficient way. This is about producing and consuming energy without the kind of carbon trail that older technologies have left behind. This is about preventing environmental disaster and still getting the advantage of what cheap energy provides in abundance. So these questions all go to the heart of, how do I apply AI to actually and practically build a real world? These are aspirational, but at the heart of it, that's really the question. The AI that I'm talking about, SparkCognition, is making that real. The idea that SparkCognition was born from was, how can we apply AI to physical systems? How can we apply AI to things that become real in the real world, things that you as a human being interact with, and that these interactions become easier and more pleasant and safer. And slowly, these systems that surround us, these planes, trains, automobiles, pumps, water systems, grid, power generation, all of the stuff that is seamless but yet so important to us as we live our lives, how can we infuse these with AI? Well, one of the challenges is that there's $100 trillion worth of infrastructure globally. So applying anything to that infrastructure that requires a rip and replace approach is just not going to happen. So AI, in my mind, became the only instrument through which this kind of intelligence could be overlaid on physical systems that already exist to make them better. And some examples of what we've already achieved in our 8.5-year journey. I'm extremely proud of the teams that have made this happen. But today, we have some of the most sophisticated visual AI capability, which is used to identify not just objects, but entire scenes, activities as they are unfurling across multiple frames. To be able to deliver safety, HSE, in manufacturing, in warehouses, in minerals extraction, and beyond. And today we have 25,000 cameras that are implementing this kind of safety and security across 16 countries. We have our maritime shipping advisor, our logistics AI, that is currently being used by one of the world's largest oil companies, and has already moved 3 billion barrels of oil so far. And when I talk about that, think about the high seas. There'll be a demonstration later on today that will explain this in depth. There might be an instance of piracy. There might be a sudden weather alert. There might be a problem with a ship somewhere. And you have a fleet of 100 tankers with various grades of product that need to get to many destinations. There might be port blockages. It's a really complex world. How do you solve these problems? Using AI. And we're doing this now, 3 billion barrels shipped on SparkCognition technology. SkyGrid, which is our premier partnership with Boeing, which we launched a couple of years ago as a 50-50 partnership. This company will change the world. This company is focused on applying all of SparkCognition's AI technology and bringing Boeing's aviation excellence to create an operating system for future unmanned systems integration into our airspace. We are going from a world where there are hundreds or thousands of aircraft that are flown manually, maintained manually, every part of the process is manual, to a world where millions of aircraft, autonomous aircraft of all shapes and sizes, will carry out missions for civilians, for companies, for governments. And the safe integration of all of these systems is a huge problem. So SkyGrid today, on its aerial operating system, is enabling flights for 30,000 drones across 100 countries. Our AI for renewables, which provides full total asset management, total plant management for solar and for wind, and increasingly in other areas, that's currently managing 8.5 gigawatts of capacity and optimizing it, keeping it safe, keeping it reliable, keeping it optimal. The sensor fusion technology that we have developed and deployed, and technology that is of singular capability, unmatched in its capability, was just fielded in one of the world's largest maritime exercises. And some of the heroic US Navy personnel that made that happen are in this audience, and you know who you are, and I'm deeply, deeply grateful to you for your collaboration with us and your service to our country. The last example I'll give you is our artificial intelligence for predictive maintenance, which is being used in a lot of different places, but is also currently being used to increase the efficacy of our United States F-16 fleet. And that is a significant deployment. The F-16 is the most numerous aircraft in the world right now. It's the most numerous fighter aircraft across the US as well as our allied fleets. And I lied, there's one more, always one more thing. Which is that we have best-in-class predictive maintenance that's now actively deployed on some of the world's largest offshore oil rigs. So going back to this dream that I had 8.5 years ago of being able to participate and being able to contribute with AI to shape the infrastructure of the world, with your partnership, with your friendship, with the support of the SparkCognition team, that dream is becoming real. And we now know that with applications of AI layered on top of existing infrastructure, we can deliver tremendous results. We can build a better world, literally, not figuratively, but system at a time. We can build a better world. And that excites me more than anything else. That's why I do this. That's what motivates our family at SparkCognition, our team at SparkCognition. And I hope we're able to get that across to you as we see demos and get into the other talks later on today. So how does this work? And if you approach us as partners and you say, okay, well, I have an infrastructure system, or I have a process, or I have a problem that I'd like to be able to automate and add intelligence to, how do I manage that? Well, what we've done is we've focused on a foundation system that we can use to build our systems and our partners can use to build and extend their systems. As an example, these are building blocks that work together. So I spoke earlier about vision. We have, again, some of the most sophisticated vision capability on the planet with both scene and action recognition. That then plugs into natural language systems. So you are detecting a scene, you're detecting objects, now you're detecting an individual carry out an act, and that act has some words associated with it. The vision system can start to create text output. Now imagine a vision system across 100 cameras in a large installation, basically talking, logging in English actions that are happening. Now all of that goes into a natural language system, so you can ask queries. You can say, did such and such event occur in the evening within an hour of this other event occurring, right? Suddenly the vision system has a memory because it output text, and suddenly that text is going into an NLP system that now adds another layer of intelligence on top. So Lego blocks that work together, intelligence combined in many different ways. Classification systems. Okay, so that happened. You saw this thing, and then I asked you the question, did it occur 27 times? Did this action occur 27 times in a day? Yes. And my classification system then tells me that, by the way, I've been watching this for many months, and anytime this particular action, maybe it's a small safety violation, somebody not wearing a hard hat, something like that, whenever that happens more than 25 times a day, there is that day, there's some sort of a safety incident. And this is highly correlated with an incident of this type. It can even tell you what type of incident. So what I'm trying to describe to you is how everything fits. You can have any type of application and apply these building blocks to those applications, but the idea is they all work together. And then you can have prediction systems. So based on all of your HSC events that your natural language and vision have now found and your classification has properly categorized, well, how many do I expect, given that I'll have 1,000 workers in the factory next Thursday? Can I expect safety incidents? How many can I expect? What could I do to prevent them? That's prediction systems. And then finally, anomaly detection systems. There are patterns happening right now. The vision system sees things which it generally doesn't see, or in these numbers, or along with that other event. It just doesn't see them, and therefore it's an anomaly and might need a little bit of research. So these anomaly detection technologies are general purpose, and they apply to sensor data that's coming in from oil rigs. It applies to vision data. It applies to really any kind of data that you throw at the system. So these building blocks and many, many others all work together with our foundation to build some of the most complete, end-to-end, robust AI capabilities for industry. And in the end, of course, once you've figured all that out, we have explainability capability that says, the AI thinks this, and this is why. Because in a lot of industries, you're not going to just take action based on what a black box tells you. A neural network saying, go left, go right. Why should I go left? And if the neural network can't give you some confidence as to why going left is a good thing, you might not go left because an improper decision might have a high cost. So explainability is another element of all of this. So now I'm going to make it a little more concrete. Today you'll see these Lego blocks combined in many, many different ways and manifested in many different systems. But that point, don't forget that point as you see the demos. You might see a thing that looks like a drone and another thing that just looks like a sensor attached to an industrial piece of equipment. And then you might see cameras being used in 8 different types of devices. But please always remember that all this hardware is coming back into our AI OS, into our foundation. It's these reusable modules that are making all of this work. So as an example, you're going to see today Perceptive Dust, which is a sensor system that can be deployed from drones that have been built here at HyperWorks. And these systems can now deploy these sensors over a large area. As soon as these sensors hit the ground, they, through vibration and other sensors, begin to transmit signals back. Those signals arrive at a machine learning system. So you can immediately tell whether a truck is going by, a car is going by, a motorcycle is going by, somebody's digging a pit to implant an IED, it's just somebody walking by casually or an animal passing by. You can easily cover an entire area and through these wireless sensors be able to develop a picture in day or night wirelessly over a long period of time. And it's a tremendous capability, for perimeter defense, for our armed services, and so on and so forth. You will see artificial intelligence and augmented reality fuse together for maintenance. You will see individual maintainers being given an iPad and being able to look at a cruise missile motor, and they don't know much about this cruise missile motor, but the sensors from that motor going into our predictive maintenance system have established that there's some type of a problem, there's some type of an anomaly. And then the natural language system has read all the manuals for this motor. So you fuse those two things together, and with AR, you look at the motor and it shows you a three-dimensional overlay, a full 3D model of the motor. And now, the recommendations from the manuals are telling you this is probably a bearing failure based on the predictive maintenance alert, but how do I change out the bearing? Well, the AR will guide you. Remove these 4 screws, and that virtual cowling appears and it gets pushed out. And you see this entire walkthrough of how you can actually do the maintenance repair. So you're taking relatively junior level people and upskilling them to the point where they can essentially deal with systems they don't know much about. And whether in our armed services, whether in our commercial fleets, whether in our utility business, these are the kinds of things that we need to do more of. You'll see a lot of SkyGrid. I've spoken a little bit about it. But you're going to have, again, drone autonomy. From a single tablet, being able to control dozens of drones, send them all off on different missions. They have sophisticated video recognition. They have infrared cameras. And for low cost, very low cost, you can create your own aerial monitoring networks. For perimeter defense, for, again, everything from a large car dealership to a large oil and gas facility to a large manufacturing plant, whatever you might have. And being able to do this, by the way, with one person, being able to record everything and use machine vision to identify whether there's a threat that any of these drones see and then take action, it's revolutionary. It cuts down burdens tremendously. You'll see a wonderful demonstration of how you can automate research with NLP. All of us have this problem. We're analysts, so we're reading technical material in oil and gas and alternatives and DOD and manufacturing. We all read technical literature. And sometimes that literature is a ton of literature and you want to just get key facts out of it. But keyword search doesn't work. So you'll see our deep NLP system where we will ingest PDFs, text, just off-the-shelf material. It's ready to go right out of the box. You ingest all of this material and you ask questions and it gives you answers. And you say, more like this, less like that. Just small amounts of feedback. And the system learns on the fly and starts to become a fully trained analyst that works side by side with you. It supports multiple languages. So that kind of research augmentation for prescriptive maintenance, it's a tremendously powerful capability. You'll see this live in action. And then you'll see our vision system for safety. Not only will you see complex scene detection, for example, are you wearing a hard hat or no? If not, you're not allowed to approach the machine to a certain distance. Does the machine have a protective cover or no? If not, and you aren't protected and you enter that area of danger, suddenly our AI system shuts the machine off. So these visual rules that you can implement through your factory floor, through your warehouse to drive safety, massive capability, massive payback, because obviously you want to save the lives and also protect your employees at all times. So lots of applications. These are just a few that I've walked you through. I haven't even told you about all the demos. Our teams are going to be here. They're going to walk you through the technology. Please ask questions. Think about it as AI Lego blocks coming together. There's a lot of large customers that have already rolled out this technology in large numbers, as I explained in my opening slide. And we would love to use HyperWorks, which, by the way, is going to continue to expand. We started with building 1, we've added building 2, we're going to add vertiports for our UAM work, we're going to add another building soon after. This is going to continue to grow as a research and collaboration campus. And I hope that much of that collaboration will be with our partners in this room now. So again, thank you so much for coming, and I look forward to everything that we will together build.